Welcome back to Science Online class. Today we are going to discuss about geometrical optics, how to draw ray diagrams for lenses. Let's see. Start of the discussing lenses, we need to know very basic things about the lenses. First thing is you need to understand what is the principal axis, what is the optical center, and what is the focal point of a lens. Today we are going to discuss about convex lenses. In convex lenses you can see at the figure 5.33 surfaces of a convex lens. Then when we are making this kind of a lens, you can see two surfaces, then each surface can make a circle. The circle center is called as C1 and second circle center is known as C2. Then when we draw a line connecting this C1 and C2, we call it as principal axis. Okay, then this principal axis is kind of a center line of this lens. Okay, horizontal one. Then figure 5.34 shows you light ray traveling through the optical center. Then optical center means the point that the crossing of the perpendicular line of the lens, this dotted line with the principal axis. Okay, this is perpendicular point. Then this middle point is known as optical center. Okay, in upcoming parts we will discuss the rays coming parallel to the principal axis and going through the optical center and going through the focal point. Then figure 5.36 shows the way the rays parallel to the principal axis are refracted by a convex lens. Okay, I told you today we are going to discuss about the convex lenses. Then you can see this is the center of curvature, center of the circle, and you can see the purple color or the blue color lines, two lines coming parallel to the principal axis, and they are getting together or crossing at the point F. This point is known as the focal point, and you can see the simple F letter. Simple F letter is used to mention the distance from optical center to focal point. Okay, this simple F indicates optical center to focal point. Then you can see a couple of dotted lines here. Okay, dotted lines here, what are they? Just think. Okay, these dotted lines are perpendicular lines which we are using perpendicular to the surface of this lens, means this is the perpendicular point. Why do we need this? Okay, you know, in these lenses we have the refraction effect. Okay, then these dotted lines are indicating the normal of normal to this interface. What is this interface? This interface is AR to glass, two mediums. Then this dotted line indicates the normal to it. Then in 2 points we have converging point, two converging points. Each point is indicated with this dotted line. After all this convergence, it become this ray going through this focal point. Okay, these are the basic things you need to know before moving to the deep end of this discussion. Okay, first thing is principal axis, second one is optical center, third one is focal point. Let's move to the basic ray diagrams. In this figure 5.37, a few special rays used in drawing ray diagrams. Okay, you can see it. Then first line, first ray type, this ray is coming towards the lens and it's moving through this optical center. Okay, then you can see no change in the direction of this ray. Therefore, we can conclude that when a ray is focusing towards the optical center, it moves without any change. Then second line, we call this ray as the ray coming parallel to the principal axis. Okay, a ray coming parallel to the principal axis. Then in here you cannot see the perpendicular lines like that, but the actual situation is I mentioned in the previous part, but in here normally when we are drawing we are not indicating these two lines. Okay, therefore no worries. Then we can just take the middle point with the dotted line which is perpendicular to the principal axis going through this optical center. Okay, then after meeting this line, it is going through the focal point. Then we can conclude that a ray coming parallel to the principal axis is going through the focal point of this object. Then light rays are having the inverse behavior. Then if it is going through this direction, it is also possible to going back in the same manner. You can this is indicated in this diagram C. It shows when a light ray coming through the capital F means focal point, then it is when after meeting the lens it moves parallel to the principal axis. Okay, you know what is the principal axis. Then this is the focal point, and this distance is the simple f. It means focal length. Okay, let's move to a small discussion about the different positions in a ray. Okay, before we are discussing this part, I would like to give you a brief introduction to the different places. Okay, then I drew the principal axis, then this is the lens, then first place is the optical center, then we have the focal point, and we have 2f twice as the focal point. Okay, just think what are the locations that we can put our object. First point is in between optical point and the focal point. This is the number 1. Then second place is normally we can keep our object on the focal point. This is the second point, and in between focal point and twice as focal point. This is number 3. And the next option is we can keep our object on the twice as focal length. Then another one beyond the focal point. Okay, basically we are considering about these 5 incidences then in this today lesson. Then as similar to this side, the left hand side, we have the focal point and the twice as focal points in the right hand side, and these distances should be equal to each other. This is the other thing. Okay, let's move to the first position. First position is when the object is between lens and its focal point. Okay, when the object is between the lens means this is the lens. Normally we can take up to this margin, the optical center, but we know optical center is kind of thing that inside the lens, because we are taking the outer margin of the lens. In this one, what are the rays that we are using in this very first incident? First ray is the ray coming parallel to the x-axis, sorry, not x-axis, it is principal axis, and it is moving through this focal point and it reach your eye. Second one, we are using the ray coming towards the optical center, and it's moving without any change. Then you can see we have used in the first one the A and the second one. Okay, A and B basic ray diagrams were used for this explanation. But you may have a problem, why don't we use this one? Yes, we can use this, but normally to identify the point of the object, this is enough. Okay, therefore we are using only 2 rays, but if you like you can use 3 basic ray diagrams if you need. Okay, but it is not essential, and in the examinations you can save your time by this method than without making much complicated scenarios. Then the other thing, we are using dotted lines. Okay, why we are using these dotted lines? Reason is this object is virtual. Virtual means this object cannot be transformed or get into a screen. Okay, get onto a screen. Therefore we are using this dotted line, because you can see the light rays are not actually meeting at this point. Okay, I will explain in the upcoming points what is this real image and virtual image, but now just remember this object is this, and this is the image. This image is virtual, upright, and magnified, okay, larger than the object. These are the features of the image which formed when object is between lens and its focal point. Okay, then next one, in all the occasions we are using the line parallel to the principal axis and the line going through this optical center. As a homework, you can try when the ray is coming through the focal point. Okay, no worries. Then in here, this one, there is actually no image because image is formed at infinity. Infinity means because these two lines are parallel. Okay, these two lines after convergence, these two lines are parallel. Therefore, we are indicating the dotted lines, no image when we have our object on the focal point. Then next one, the image of an object placed between the distances f and 2f. F and 2f, 2f means twice as the focal point. Then in here, again we are using the line parallel to principal axis and it is going through the focal point, and second one is line going through this optical center. Okay, then you can observe that this object is moving away from the twice as focal point, focal length point, this f dash. Okay, in this one also the image size is quite large, but it is inverted. Inverted means it can be this object can be downward. Normally students are thinking that inverted means always it should be down. In this think about the condition that red arrow, red object, then this is also inverted condition. Now I think you can realize normally this line, okay, which is coming parallel to the principal axis and going through the focal point is quite a similar. Okay, nothing changed, but when you are looking at this one, you can observe that this line is very crucial for the position of the image. Okay, then we will see and we can experience it with the next one very well. Then image of an object when when the object distance is 2f. Now the image size equal to the object size. Okay, you can see again principal the ray coming parallel to the principal axis moves through this focal point, but when this ray coming towards the optical center and moving away without any change away from the optical center is quite changed, and basically this angle affect to this change. Okay, because in the same diagram we can draw it. Okay, then think about the condition. Now our object is on the f, this line is same. Okay, but you can see when we are drawing this optical center one, okay, this kind of thing, because you experience it, this is going parallel to this first line, and you can see this angle is quite larger. Okay, angle is quite larger. That is the changing point of the location and the size of the image. Okay, in here normally we can remember that inverted images are real and this upward, okay, the upright images are virtual. This kind of thing is there, but when you are drawing and doing the questions, it's better to draw the ray diagram. If you are genius, you can just remember the things. Okay, now we are going to consider about the last point of this. Then this time object placed at a distance greater than 2f. 2f means twice as the focal length. Then the first ray is the ray parallel to the principal axis and going through the focal point. I told you there is not much difference, so there's not much effect of this ray, because we are using kind of to draw any image we need two rays. Okay, that's why we are using this. Then the critical one is this. Okay, optical ray diagram, sorry, the ray going through the optical center and it changed. Now you can see this angle is little bit reduced angle. Then what happened here, then you can see this image is shorter or image height is low, or the image size is reduced in this manner then than the object size, and also it is inverted image. Inverted means it becomes real. Okay, then we have the summary. Wait, don't go. I'm going to show you some interesting software or this web platform that you can use for your works, for studies. Okay, wait a minute until I finish this table. Image formed by convex lens, we can have the summary of the previous discussion. Then object distance less than the focal point. Then we have virtual upright one, I told you upright ones are virtual and larger than the object. Then next one, focal point, image position of the image infinity, greater than focal length and less than twice as the focal point. At that point we have real and inverted. You can see this interesting point. The one and only difficult point or the different point is this one, less than focal point, and all the other positions are making, okay, not except this point, all the other positions are making real and inverted ones. But the what is the changing factor? There should be one, no? Then the changing factor is less, image size is reduced. Then you can make a relationship like this. Okay, you can see larger than object, larger than object. In here no object, no image. Okay, no image. Then larger than the object, same as the object, and the smaller than the object and much smaller than the object. Then what happens, you can kind of remember like this: when your object is moving away from the optical center or the lens, what happened to this one, your image is becoming more smaller. Okay, when you are going away, your image becomes more smaller. Okay, your image formed become more smaller. Therefore you can remember like this: object distance is, okay, not the always, but it is kind of a tip to remember, kind of inversely proportional to the size of the image. Okay, size of the image. Then what you can say, object distance means object between the object point and the lens. Okay, object distance is inversely proportional to the size of the image. This is just a tip or the hint. Then you can see when your object distance is high, like twice than 2f, then in between f and 2f, likewise, then your image size, what happen, it reduces. Okay, same as the object size and smaller than the object and much smaller than the object. Then I am giving a small tip to remember this relationship. Then you can remember that twice as the focal point, in here we have the same as the object size. Then upward that, the upper positions, they are larger than the object size, and the lower ones, when you are going away from the twice as the focal point, focal length, then your object becomes smaller. This is the simple relationship you can practice, and you can remember this chart very easily. Let's move to the website that we can practice this different positions. This site's name is Physics. Then I put the link for this point in my description. Okay, you can follow this and you can move to this lens. In here you can see the focal point and the object position. What you need to do is you can change the focal point. Okay, just take it like this. Then in here you can change the focal point. As I mentioned earlier, in here in this platform they are using 3-ray diagrams. Okay, actually it is not essential for yourself, then you can use only 2 ones. Then here interestingly I am going to show you the 3 different types. Then I'm taking the focal point as 2 and I'm taking the object size as 1 and this kind of thing. Okay, then carefully look at this center line which is going through the optical center. Okay, which is going through the optical center. Then you can observe this line is not changing. Okay, the ray coming parallel to the principal axis is not changed, but the angle of this center line is changing. Then when you are moving away, the object becomes more smaller. Then when you are moving towards the focal point, this object becomes much larger. And I told you these dotted lines indicates the virtual kind of virtual image which is larger than the object. And you can see this is also upright and our object is as the same as the objects. Then this is the inverted condition. I think you can comment about this one in my comment section, and we will see what we can do with the mirrors. Okay, goodbye. Don't forget to subscribe my channel and